right, welcome to our next lesson on stoichiometry. So this is like part 2 of stoichiometry. We're still working on the same learning objective, so we're going to be using given information to convert from grams or moles of one substance to moles or grams of another substance. Now keep in mind, last time that we talked about stoichiometry, we were just going from moles of one substance to moles of another substance, and we were looking at our balanced chemical equation for that. Today, we're going to be talking about going from moles to mass or mass to moles. Okay, so as I previously said, we already did mole to mole stoichiometry on our last lesson, and you guys should have done practice with those. Today, we're doing mole gram stoichiometry or mole mass stoichiometry. So this is when given a mass of one substance, they're asking us to find the moles of another substance in the reaction. Or they might give you the moles of one substance and you need to find the mass of the other substance. So you can start off with moles and get to grams, or you can start off with grams and get to moles. And keep in mind that with stoichiometry, it is always going from one substance to a different substance. So we want to know what the end result is in a different substance than what we started with. Okay, so for example 1, this chemical reaction should look pretty familiar to you. So this is what happens in plants undergoing photosynthesis. So if you remember from biology last year, plants are going to take in carbon dioxide and water, and then along with sunlight is going to convert it into sugar or glucose and oxygen. Okay, so the first thing I'm going to do, always do this when you start a stoichiometry problem, is make sure that your chemical equation is balanced. So just going to double check up here. It looks like I have 6 carbons on both sides. I have 12 hydrogens and then 18 oxygens on both sides. So we have a balanced chemical reaction, which means we can proceed with our problem. So the problem asks how many grams of glucose are produced when 24.0 moles of carbon dioxide reacts in excess water. All right, so for this problem, first thing I'm going to do is pick out what is my given and what is my wanted. So in the problem, it tells me that I'm going to have 24.0 moles of carbon dioxide. So that's going to be my given. And then what I'm solving for is my wanted, and it's asking me how many grams of glucose. So I know that grams of glucose is going to be my wanted. Now, along with labeling it in the problem, I'm going to also label it in my balanced chemical equation. So I'm going to circle glucose, that's going to be my wanted, and carbon dioxide is going to be my given. So these are the only 2 substances that I should have in my dimensional analysis grid. All right, the next thing I'm going to do is look at this flow chart that we have. So I'm going to see where are we starting and where are we ending. So it looks like it's giving me 24.0 moles of the given, the carbon dioxide. So this is where I'm starting. And then I'm trying to get to grams of glucose, or the wanted. So this is where I'm ending. All right, so I know that I'm going to have 3 columns in my dimensional analysis grid. So I'm just going to set that up right away. Okay, now I can proceed with the problem here. So what I'm going to do is put my given in the upper left-hand corner like I usually do. So I'll put my 24.0 moles of carbon dioxide right here. All right, so I'm going from moles of given, first step, to moles of wanted. Now keep in mind with dimensional analysis and stoichiometry, the only 2 things that we can use are going to be the mole ratio or a molar mass conversion or equal statement. So I'm just going to abbreviate it, molar mass equal statement, and this is really an equal statement as well. So if I want to go from moles of one substance to moles of another substance, I have to look at my balanced chemical equation. All right, so my balanced chemical equation, remember, is giving you the ratio of how many moles of this to how many moles of that. All right, so the moles of given, remember, given is going to be my CO2, and it looks like I have 6 moles of that. Where the moles of wanted, since I don't have a coefficient in front of my glucose, it's just going to be 1 mole. All right, so then I'm going to say, oh, this is my equal statement. 6 moles of CO2 is equal to 1 mole of C6H12O6. Oop, that should be a subscript. So how am I going to fit this into that next column so that I can get to moles of glucose? All right, well, I know that I have moles of carbon dioxide up here, and I want that to cancel because I want to get to moles of glucose. So I know that from my conversion factor, my equal statement, my mole ratio, I'm going to put the 6 moles of CO2 down here so that I can cancel them out. And then I will put the 1 mole of C6H12O6 here. All right, so now I got from here to here. My next step, I have to go from the moles of wanted to the grams of wanted. Now, the way that we go from moles and to grams of the same substance is going to be that molar mass equal statement that we're going to make. Keep in mind that the molar mass equal statement, I'm just going to write the equal statement up here, is always going to be 1 mole of the substance. So the substance is going to be my glucose, so C6H12O6. And to find the molar mass, I'm going to have to look at my periodic table. So 1 mole of C6H12, if you add up 6 carbons, 12 hydrogens, and then 6 oxygens, you are going to get, using your periodic table, gold periodic table, 180.156 grams of C6H12O6. All right. Sorry, I'm running out of room here, but that's all right. All right, so now this is my second equal statement or conversion factor. I want to get rid of moles and I want to get to grams. So what I want left is going to be grams. I know that that's going to go up top on my dimensional analysis grid. So I'll put the 180.156 grams of C6H12O6, and then I will put the 1 mole of C6H12O6 on the bottom. So I just took it straight from this equal statement, right? So I'm going to cross out my moles of C6H12O6, and then my unit that I'm left with is going to be grams. Okay, so if you take 24, you multiply it by 180.156, and then divide by 6, your calculator should give you 720.624. I'm just going to round that to 720.6, and I know that my unit that's going to be left is going to be grams of C6H12O6. So if I have 24 moles of carbon dioxide with excess water, I can produce 720.6 grams of glucose. Now I know that you could just, I don't know, ask Google or Alexa or Siri, you know, how many grams would I get if I had 24 moles of CO2 with this equation? And she would be able to spit that out for you right away. So you're not going to get the points on your homeworks or on any assessments that I do unless you are showing all of this work. All right, you should be showing all of this. You should have your given in the upper left-hand corner. Think of that as like a point with the unit and the label. In this next column, make sure that you have your 2 parts of your equal statement in the right spot so that they cancel out. Make sure that you have units and labels on everything, because showing your work is going to give you points. All right, if you, for some reason, type this in incorrectly into your calculator and you did not get this answer, at least I'd be able to look back at your work and be like, okay, you set it up correctly. You just must have hit something wrong in your calculator. So you wouldn't get all those points off. If you have any questions about that, definitely contact me during my office hours or send me an email. Okay, so for the next one, we're going to use that same chemical equation. Remember that it was already balanced. I don't have to balance it, but you should always be making sure that it is balanced before you move on in your stoichiometry problem. This one is asking how many moles of O2 or oxygen are produced when 315.43 grams of carbon dioxide reacts in excess water. First thing I'm going to do is pick out my given and my wanted. So in my problem, it's saying that I have 315.43 grams of carbon dioxide. That's going to be my given. And then I'm solving for how many moles of O2. So this is going to be my wanted. So with O2, I'm going to circle that. And then I'm also going to circle the grams of carbon dioxide. So here's my given, here is my wanted. All right, I'm gonna look at my flow chart and see where I'm going to and where I'm coming from. So if I'm starting off with grams of carbon dioxide, I'm going to be starting off with grams of given. So here's like my starting point, and then I'm trying to get to moles of O2. So this is where I'm going to be ending. So I'm going to have 1, 2, 3 boxes again in my dimensional analysis, or columns, I should say. So 1 column, 2 columns, and then I have 3 columns there. All right. I'm going to set it up the same way that I set up the other one. I'm going to put my given in the upper left-hand corner. So I'm going to put my 315.43 grams of carbon dioxide here. All right, so I want to go from grams of given to moles of given. So we, in order to get from the grams of a substance to the moles of that same substance, we're going to have to use that molar mass equal statement. So that's telling us how many grams is in 1 mole of carbon dioxide. So my equal statement that I would make would be 1 mole of carbon dioxide is equal, and then I would add up 1 carbon, which is 12.01, plus 2 oxygens, which is 32. So 32 plus 12.01, you should get 44.01 grams of CO2. All right, now I'm going to look at my equal statement. I'm going to determine which one's going to go on the top, which one's going to go on the bottom in my next column. Since I'm starting with grams of CO2, I know it has to cancel out. So I know that the 44.01 grams of CO2 would have to be in the bottom. So I know that that's equal to 1 mole of CO2, or the other part of my equal statement here. All right, so I got rid of grams of CO2. Now I'm in moles of CO2, but now I have to go from moles of CO2 to moles of oxygen. And the way that I do that is in my balanced chemical equation. I have to come up with the mole ratio. So I'm going to look at both of those coefficients, which are going to tell me how many moles each of them has. And it says that 6 moles of CO2 is going to be equal then to 6 moles of O2. All right, so I'm going to look here. I'm going to determine which one's going to go where in this last column. So since I have moles of CO2 here, I need to have moles of CO2 here, and then my moles of O2 would go up top. Okay, so when you type 315.43, multiply that by 6, and then divide by 6 and divide by 44.01, your calculator should get you 7.16723472, probably more numbers if you have more spaces for digits. I'm going to round that to the, let's round it to the hundredths place. So we'll do 7.1, and then that 6 rounds to a 7, so it would be 7.17 moles of O2. So we just solved if we have 315.43 grams of carbon dioxide, we would be able to make 7.17 moles of oxygen. All right, so I think the best thing that we can do with this is to make sure that you are showing all your work and you're taking those pre-steps before you put everything in your dimensional analysis. So keep in mind that with stoichiometry, we can only have 2 different types of equal statements, okay? So we can only have a molar mass equal statement or a mole ratio equal statement. All right, the molar mass equal statement is going to be specific to each kind of substance that you have, right? Because you know that 1 mole of oxygen isn't going to be equal to 1 mole of carbon dioxide grams wise, right? So 32 grams versus 44.01. So my molar mass equal statement, something to just keep in mind, is that it's always going to be 1 mole of the substance. We'll call it substance X. And that's going to be equal to whatever we get from our periodic table using the subscripts to grams of substance X. All right, so make sure that you always have your units, so you moles, grams, and then your label for your substance. The mole ratio is going to come from your balanced chemical equation. So this is going to be comparing the moles of different substances. Notice that this one, you're having the same substance. The mole ratio is of different substances, and the only way we can compare different substances is by having a balanced chemical equation. So an example would be like 2 moles of X is equal to 3 moles of substance Y. So you really have to pay attention to what you are canceling out and what your next step is. That's why I think it's really important that you use that flow chart. So remember, if you're starting with grams of given, going to moles of given, moles of wanted, and then grams of wanted. All right, if I'm going from grams of given to moles of given, I'm using my periodic table, and this is going to be my molar mass. If I'm going from moles of given to moles of wanted, this is where I used my mole ratio, and that's going to be from my equation, balanced equation. All right, and then finally, if you wanted to go from mass of your wanted to grams of your wanted, you would again use the molar mass, but think about it, this is going to be a different substance now because it's the wanted substance, not the given. So the molar mass, and that's where you look at your periodic table. I would highly recommend making these notes on your flow chart. I think it'll help you a lot. So if you have any questions, please reach out to me. I can answer a lot of questions by email, but if we do need to do some sort of chat, we can figure that out as well.